Now let's look at some applications of exponential functions and logarithmic functions. These are examples kind of related to what's in your textbook. So if you want to have your textbook near you, that would be all right. These are different examples that are in your book. These are the checkpoints. Ultimately, there is this exponential equation. That is a 6. This is e to the 12.77x power. And what this exponential equation represents is there x equals, and you're going to love this, the blood alcohol concentration in a person, and R is going to represent the risk of having a car accident. And of course, this is as a percent. So we're going to use the formula. So we're going to use the formula to find the blood alcohol concentration for a 7% risk. Okay, so ultimately R is 7, so R is 7, and we are going to solve for x. So we're going to have 7 equals 6e to the 12.77x power. First thing we're going to do is divide by 6. I'm going to leave that as a fraction. I know, my other favorite F word. It's going to equal 7 over 6. I just flipped over that equation. Don't let that scare you. Now, what log am I going to use? Natural log or common log? Well, e is in the equation, so I'm going to use natural log. So take the natural log of both sides. That's going to make this go bye-bye. And you're going to be left with 12.77x equals the natural log of 7 over 6. Now we're going to divide this by 12.77. So x equals the natural log of 7 over 6, all divided by 12.77. Since I have x all by itself, it's safe to touch the calculator. And the blood alcohol concentration would be 0.012. The next application we're going to do has to do with compound interest. Okay, so in section 4.1, we learned that the compound interest formula, the final amount was equal to the principal times 1 plus r over n to the nt power, not at, that's nt power. Or, and this is for compounding monthly, weekly, whatever, blah, 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 or a equals p times e to the rt if it's compounded continuously. So this one is continuously compounded. These are for all other compounding. Okay, so you have to pay attention to what type of compounding. Ultimately, we're going to answer this question. How long will it take to grow $1,000 to $3,600 at 8% interest, compounded quarterly? Okay, so that's what we're solving here. So we're compounding quarterly, so we have to decide which compounding formula to use. It is not, say, compounded continuously, so that's not the one we're going to use. Here is our formula. A equals P 1 plus R over N to the NT power. All right, we know our final amount, we know our initial amount, we know the number of times compounded per year, we know everything except for T. So let's substitute everything we've got. Our ending amount is 3,600. Starting amount is 1,000. 1 plus 0.08 over 4 to the 4T power. Okay. Simplify some things as we go. The first thing we're going to do is divide by 1,000. So we're going to have 3.6 equals 1 plus 0.08 over 4 to the 4T power. Simplify what's in there. I should have done that first. 3.6 equals 1.02 to the 4T power. Use a log. It does not matter which log you use, whether you use common log or natural log. I'm going to use common log. So I'm going to do the log of 3.6 equals the log 1.02 to the 4T power. All right, use that property of logs that says we can bring this down in front. That's the power property. So the log of 3.6 equals 4T times the log of 1.02. Not touching the calculator. I'm going to divide both sides by 4 log 1.02. And we're going to have T equals the log of 3.6 divided by 4 times the log of 1.02. I hope you noticed I put parentheses around that denominator because that's what you need to do in your calculator. If you don't, then your calculator will take the log of 3.6, divide it by 4, and then multiply it by the log of 1.02, which will not be correct. So make sure you use those parentheses. T is going to equal 16.2 years. The last one application that I'm going to do has to do with a growth chart and a model for the growth of a child. So there is another one in your book. This one I was going to talk about the growth of a girl. The one in your book is the growth of a boy. So here, X is going to equal a girl's age, and it's got to be between 5 and 15 years, from 5 to 15. And f of x, this function, is going to equal the percent of the adult height. So my question is, we're going to use this function. At what age will a girl attain 97% of her adult height? Okay, so using this function, I'm giving you the percent. So f of x is 97. So 97 equals 62 plus 35 log of x minus 4. Okay, so we got to get the log all by itself. So we're going to subtract the 62. 35 equals 35 times the log of x minus 4. Divide by 35. 1 equals the log of x minus 4. Oh, looky there. It's a 1. That's kind of convenient. This is a common log, so that means the base is 10. So 10 to the first, switch to exponential form, equals x minus 4. That's convenient because 10 to the first is 10, and we add the 4 over. X equals 14. So when a girl is at 14 years old, she will have attained 97% of her adult height.